Have you ever stopped to wonder, how do we actually know where anything is on our planet? It seems like such a simple question, right? But the answer is this brilliant, invisible system that organizes our entire world. So let's dive in and see how this whole thing works.
I want you to picture this. You're floating in the middle of the Pacific Ocean. No street signs, no landmarks, nothing. How in the world do you tell someone your exact location? It feels impossible. And yet, centuries ago, humanity came up with this beautiful, elegant solution. Okay, so first things first, we need a model to work with. And the Earth isn't a perfect sphere. It's actually a little bit squashed at the poles and kind of bulges out in the middle. The best way to really visualize this is with a globe, which is a true miniature model of our planet. So, to get our bearings, we have to start with an imaginary line. Think of it like a knitting needle that's been pushed right through the center of the globe on a tilt. And the two spots where that needle would poke out, those are our first absolutely crucial reference points, the North Pole and the South Pole. All right, so we've got our poles. Now we can tackle the first part of this big location puzzle. How do we figure out how far north or south something is? Well, to measure anything, you need a starting point, right? For north and south, that starting line is the equator. It's another imaginary circle, and it wraps around the widest part of the Earth, exactly halfway between the poles. This is our 0-degree marker, and just like that, it splits the world into two halves, the northern hemisphere and the southern hemisphere. Now, running parallel to the equator, you've got all these other circles. We call them parallels of latitude. Think of them like rungs on a giant ladder that let us measure our position north or south in degrees, from 0 at the equator all the way up to 90 at the poles. And a few of these have special names you've probably heard of, like the tropics and the Arctic circles. They're pretty important. But here's the cool thing. Latitude isn't just about your north-south position. It actually plays a huge role in determining climate. And it all comes down to the angle of the sun's rays. Let me show you what I mean. Okay, think about it like this. Grab a flashlight. If you shine it straight down on a table, what do you get? A small, really bright, intense circle of light, right? That's what the sun is like near the equator. But now, tilt that flashlight. See how the light spreads out? It covers more area, but it's way less bright, less intense. And that is exactly what's happening near the pole. So these different sun angles, the direct ones and the slanted ones, they create three totally distinct heat zones on our planet. You've got the torrid zone, right between the tropics, that gets blasted with direct sun and maximum heat. Then you have the temperate zones with more moderate temperatures. And finally, the frigid zones way up by the poles, which get those weak, slanted rays, making them very, very cold. Okay, so we've totally nailed the north-south problem. But what about east and west? That's the whole other half of the puzzle, right? This brings us to the next layer of our global address system. And here's why we need it. Take a look at this. The Tonga Islands and Mauritius, they are both located on the exact same line of latitude, 20 degrees south. But they're on completely opposite sides of the planet. So yeah, just knowing your latitude, it's not going to cut it. The solution? A whole new set of lines. These are called meridians of longitude. And unlike those latitude lines, these guys are not parallel. They're actually semicircles that all run from the North Pole down to the South Pole. Kind of like the segments of an orange, if you think about it. Now, here's a tricky part. All these longitude lines are the same length. So which one do you pick as the starting line? It was kind of arbitrary. Eventually, everyone just agreed that the meridian passing through the Royal Observatory in Greenwich, England, that would be the 0-degree line. We call it the prime meridian. And just like the equator, it splits the world in two, the eastern and western hemispheres. So we've got our north-south lines and our east-west lines, and when you lay them over top of each other, bam, you get the complete solution, the global grid. All right, so let's do a super quick recap of the difference here, because it can be a little confusing. Remember, latitude lines look like they run east-west, but they measure how far north or south you are. And longitude lines run north-south, but they measure how far east or west you are. It's this brilliant system of crisscrossing measurements. And this, right here, is where the magic happens. It's the intersection. When you combine one latitude with one longitude, you get a unique coordinate, a precise address for any single spot on the entire planet. No exceptions. Okay, let's make this real. Say we want to find the city of Dhubri in Assam. First, you'd find that 26 degrees north latitude line. Then, you find the 90 degrees east longitude line. And the exact spot where they cross, that's Dhubri. It's so simple, but it's unbelievably powerful. But wait, there's more. This grid doesn't just tell us where we are, it also tells us when we are. Yeah, this whole system is actually the foundation of all global timekeeping. And the math behind it is actually pretty simple. Check this out. The Earth spins a full circle, 360 degrees, in about 24 hours. So if you do the math, 360 divided by 24, that means the Earth rotates 15 degrees of longitude every single hour. And if you break that down even more, it's 1 degree every 4 minutes. And the key to all of this is a super simple rule. The Earth spins from west to east. That means if you're east of Greenwich, you're ahead in time. You see the sunrise first, and if you're to the west, you're behind. Let's use a real example to make this stick. India's standard time is based on the 82.5 degrees east line of longitude. So if we use our math, 15 degrees an hour, that puts India exactly 5.5 hours ahead of Greenwich Mean Time, what we call GMT. So what does that actually look like? Let's say a cricket match starts at 2 o'clock in the afternoon in London. All you do is add those 5.5 hours. And that means, in India, people are tuning in at 7:30 in the evening. See? It's all just longitude. Now, obviously, to keep things from getting totally chaotic, the world is divided up into 24 standard time zones. Each one is roughly 15 degrees of longitude wide. But for really huge countries that stretch across tons of longitude, like Russia, well, one time zone just isn't going to work. They need a bunch. Russia has 11 of them. Can you imagine? So there you have it, a brilliant system of imaginary lines that lets us pinpoint any location on Earth and keeps all our clocks in sync. It's this invisible framework that literally organizes our entire world. And it kind of makes you wonder, doesn't it? What's the next big invisible system that's going to come along and change everything?